Hello everyone, I am Uday and welcome to my channel Tech Wall. Today in this video I am going to make a project called IoT based temperature and humidity monitoring system using ESP32 and DHT11 sensor. The main parts we need for this video are ESP32 microcontroller, some jumper wires, DHT11 sensor for temperature and humidity detection, and a connecting from cable of micro USB to USB to connect to our laptop. And we also have to open an website called ThinkSpeak. This DHT sensor is a sensor which I'm going to explain now. This DHT sensor is one of the most popular low-cost digital sensors for measuring temperature and relative humidity. It is widely used in Arduino, ESP32, Raspberry Pi, and IoT Project because it's easy, cheap, and provides a calibrated digital output. This contains a capacitive humidity sensor inside and an NTC thermistor for temperature. It has an internal 8-bit microcontroller that handles signal processing and outputs data digitally. Now I'm going to explain about this ESP32. This ESP32 is low cost, low power microcontroller with built-in Wi-Fi and Bluetooth developed by Expressive Systems. It is the most popular chip for IoT tech projects, that is Internet of Things. It has a dual-core 32-bit LX6 processor which can process up to 240 MHz. It has wireless Wi-Fi and Bluetooth 4.2 and plus BLE. Its memory is 448 KB ROM, 520 KB SRAM, 4 MB SPI flash. The voltage is 3.3 voltage. That is the operating voltage of this thing, ESP32. The temperature reading can be done from minus 40 degrees Celsius to plus 125 degrees Celsius. It has 34 plus GPIO pins with ADC, DAC, DAC, PWM, I2C, SPI, and UART. It is a special Hall sensor, capacitive touch sensors, and crypto accelerator. This is popular because it has built-in connectivity, dual-core processing, multiple programming options, and its small size is very comfortable and compatible. It's also compatible with Arduino, so it's very popular. Yeah, so now let's start connecting. So first we have to see what is given in this thing. There is VCC, data, that's DAT, and GND. VCC stands for positive voltage, that is 3.3 voltage, which is provided by the ESP32, and the ground is negative terminal, and DAT stands for data. That means it can be used to send data. The sensor to ESP32, which can be sent through Wi-Fi to ThinkSpeak, which we can see, and I'll talk about that later in the video. Now, let's start the wiring. So let's get started. Grab some female to female wires and let's get started. So we are connecting the data, that is this pin, the purple pin, to the DH4 on ESP32. I mean D4. The connections are done. We connected the D4 to the data and VCC, I mean 3.3 volt to VCC, and ground to ground. You can see the connection as follows. Now let's connect this cable to our laptop USB. As you can see, I connected to my laptop pin. Now the LED light is glowing. That is the power LED has turned on for ESP32 and the DHT11 sensor. Let us look at the coding about how to code it and what to do in the ThinkSpeak. This is ESP32 development board. So remember that and let's head on. Now this is the code which is written for this project, IoT project, to work. I'm going to explain the code line by line, but first let's select the board. So there are many ports. Select the port in which you kept. Let us see COM7, and here is your USB. So I am correct. Now type ESP32 dev module. Yeah, we have selected it. Now let's click OK. Yeah, now as you can see, this is selected. We can upload the code now, but first let us try to understand what the code actually means. Yes, so now we can see the code. The first line is include dht.h. It means that dht.h is the library for DHT11 temperature and humidity sensor which we are using in the video. The next line is Wi-Fi.h. This allows the board to connect to the Wi-Fi in your home. The next line is include ThinkSpeak.h. This ThinkSpeak this line allows us to send data to ThinkSpeak cloud, which I will talk about when we open the website. Next is Wi-Fi client. Here we are creating a Wi-Fi client object. ThinkSpeak uses this object to communicate over the internet to send us information and data. Next is DHT 4, DHT 11. This creates a DHT sensor object and the data pin is connected to DHT 11 and DHT 11 is sensor type as we have connected in a video previously. Now is void setup. It's just a function which only runs once when the board starts. Serial data begin 115200. This means that it starts serial communication at 1,15,200 baud rate, and it's used to print the values to serial monitor. Next, ThinkSpeak. Next line is DHT begin. This starts the DHT sensor. After this is Wi-Fi.begin SSID.password. Here the Wi-Fi begins at the SSID which you enter as Wi-Fi name and the password which you enter which is required to connect. It attempts to connect to the Wi-Fi network. You may ask, how do you know that the ESP32 and DHT are connected to the Wi-Fi or not? So that's why I wrote the line 15, 16, 17, 18. So here we have while loop. This is a while loop. So it says that while Wi-Fi status not equal to W connected delay 500 serial print ln connecting to Wi-Fi. This means that while the Wi-Fi, that means when the Wi-Fi is not connected to W connected, Wi-Fi is not connected to the thing which we mentioned, then it waits for half a second, that is 500 milliseconds, and prints connecting to Wi-Fi every half a second. This continues until the Wi-Fi is connected. Once it's connected, it breaks the loop, and the next line starts. That is, next line serial print and Wi-Fi connected. That means the Wi-Fi is successfully connected. Now ThinkSpeak the begin client. This means that it initiates the ThinkSpeak library and uses the Wi-Fi client created earlier. Now, next, this is the void loop. Void loop is a function which runs continuously without ending. So first, we are creating variables called float t. That means float means all decimal values. For example, 5 we can written as 5.0 and 5.2 is anyway a decimal value. So we are creating a variable t which is a float type, that is dht.read temperature. That means this reads temperature from DHT 11 and stores in the variable t. For example, if the temperature is 31, then it stores 31. Next is float h. Similarly, float h is a float type, and here instead of reading temperature, it reads the humidity and stores in the variable h. For example, h is equal to 65, something like that. Next, it prints the serial prints the temperature. That means it prints here this exact line, temperature because we kept quotes and apostrophe. That means it prints the exact same line. And then serial.println means it prints new line, the variable t, which is the value. Similarly, happens for humidity, which prints the humidity serial.print, and serial.println h, which prints the value of h. Next, this is thingspeak.writefield channel ID, 1, t API key, same as for 2, and delay is 15,000 milliseconds, that is 15 seconds. These two lines tell us that this line tells us that first is channel ID. That means you have to write ThinkSpeak channel number. Next is one is field number. Next is temperature value and the API key. This is a secret key that allows writing data. The same is for the second one also. The channel ID will be same, but the field is second field because it's the second field, and then well it just continues on. Because of this, the ThinkSpeak dashboard that is on the website with visual graphs. Now let's go to the ThinkSpeak website and do the graphing and get the data. But first, let's just upload the code. To upload, just click upload. Once you click upload, it will first verify the code and compile it, and then it will upload. So let's wait. So we are not uploading because I have to explain this 4 lines, and we have to write the API keys and this channel ID. So this is just very simple. Just a variable is constant, com is constant character, same as this unsigned long is it's non-negative integer, and it's can be any long digits up to I think 256 bytes. First just open any browser. Yes, what I'm saying is open any browser and type ThinkSpeak. Then you will get the first thing which is shown here. So now I will explain what is ThinkSpeak. So ThinkSpeak is a cloud platform used to solve, visualize and analyze sensor data received from the IoT devices using MATLAB. I signed in, so I can just click my account, but you have to sign in, and then you get here something like my account. Well, I'm using a free account, so just go to my channels, create a new channel, and we'll type the name. I'll just type it. So well, I'm just done writing this name, this kind of field 1, field 2, and just now all you have to do is just save the channel. Yes. So you can see this is the temperature chart, field 1, and this is field 2 chart. Here are which is your data. So just quickly copy these API keys and all these things. Write API key to this key to the right API key in the API keys 2 and copy that. The channel, here is the channel ID 3405871. So you can just copy the channel ID also. Now let's just paste the API key, and also we just recopy the channel ID and paste that too. Yes, so now we are completely done with the code, and you can just click this upload button. So once you just click the button, we just got this thing, and well, just notification came done uploading. So let's just check the output now in the ThinkSpeak. Let's check the serial monitor. We set the border to that, and now the output is coming every 15 seconds. Temperature and humidity. Now let's check on ThinkSpeak. So let us just check it real quick. Yes, temperature detection is working, and the humidity detection is working. I just changed the temperature detection by mistake, but don't worry, that's just a channel name. But I'm so happy and thankful that this is working. The temperature, this is working since a long time, and I figured out the humidity is still working. I mean, of course, humidity cannot change like every single second or every single minute, but temperature like can maybe change. But I'm still glad the thing is working properly. So well, thank you guys. Thank you for watching the video. If you enjoyed it, please subscribe to my channel. And also, this is for PlayTo Labs RoboCap Relic for the red RoboCap. And yeah, so everything's working properly. So I hope you give me a red RoboCap very soon. And I'm hoping for it. So then, bye.
वीडियोस बनाने हैं, फिल्मोरा है ना।